So today we will learn how to use. Today we will design the storm sewer network using StormCAD software. So basically, this is the storm sewer network problem. Uh, First of all, we will make this network on the StormCAD software, and then we will provide these informations, this given information of the inlet and the pipes. Then we will design the pipe size and their upstream and downstream inward elevation. So when we are going to design the storm sewer network, so basically for the inlet design we are interested to determine its sump elevation. So this is sump elevation. This is totally the inlet structure. So this the bottom is called sump elevation, and this vertical height is called sump depth. Basically it is used to accumulate the sediments. So this is the pipe inward, and this is the crown, this is cover, and this is the ground elevation. So here there is the rim. So most of the cases rim elevation and the ground elevation is the same. So when we are interested to design the storm sewer network use StormCAD, so basically we are interested to design the basically sump elevation and pipe size and their inward and upward slopes. So this is the software, StormCAD software. I will open it, click yes. Okay, so right now we will create new project. So click on the new project. Okay, so here we will write it example storm tutorial. Okay, so now we have project title, just next, and here we have to select schematic because we are not using the scale, because we don't have any CAD file. We will use the alignment scale as a schematic. Just finish it. Okay, so this is basically the window, and first of all we have to set the units system. So we will go to the option. So here you notice that system unit system, so we will use system international, and click OK. Now this option pipe network is very important. So when we click here, okay, so right click here, you can see there the first inlet option. So inlet option, one inlet is provided, and then there is second inlet, and this is the third inlet, but it will be our outlet. So we will and press okay, just Control Z. Yes. Here you first of all see the network. So there are basically three inlet, I1, I2, I3, three pipes, P1, P2, P3, and one outlet. So we will draw this network on the StormCAD. Go to this command and click on the inlet. This is our one inlet, second inlet, and this is our outlet. Okay, so we will click again because we have to draw the I3, and just click okay, just click here and skip. So here you notice that we have drawn our network. You can easily, by selecting, you can easily drag and make the network alignment because it is schematic one. So here we have drawn our network, which have three inlets and three pipes and one outlet. Okay, now our second step is to put the informations. Okay, so when we right click on the inlet, so this inlet tab has been opened. So here the information, the general. So label name, so it is I1. So ground elevation, so here what is the ground elevation? 42.8. 42.8. Okay, and the other one is set rim equal to ground elevation. Exactly, we will make ground elevation equal to our rim elevation. Here you notice that, so this is the rim elevation. In most of the cases this rim elevation is equal to the ground elevation, so we will take it same as that of the ground elevation. So some elevation we have to design it, so we will keep it 0. So coming for the head loss method, in the question, the head loss method, we have been asked to choose the standard one. Yes, so that is standard head loss method, and its coefficient is 0.5 and length is 0.5. So by default is absolute head loss method, but we will select standard method and its coefficient given is 0.5. Okay, so leave other things that we don't put any value in the divergence. Now in the catchment, so time of concentration is 15 minutes. Okay, we will add it 15 minutes, and here it is given time of concentration 15 minutes, and in the catchment we have been asked to enter the value of area, catchment area, and inlet C. So area is 0.67 hectare and inlet C is 0.7. Just click here, 0.67 and 0.7. So in this way, by default the area unit is hectare, but we can change its unit as well. Here, going to the area properties, here you can change the unit, but we will choose the hectare as given in our statement. So this is the inlet coefficient C, we have used it. Now coming to the inlet information, so the inlet characteristics, we have been asked to choose the grade 1. Here is grade D1 1A. Okay, and his standard head loss is 0.5, length of 0.5, and clogging factor is 20%. So D1, grade D1 1A. Okay, that is grade D1 1A. Okay, fine. And grade length is 0.5 and clogging factor is 20%. Right, 0.5, and the clogging factor is 20%. Okay, so the other one is inlet section, that is for the rod cross slope. So the rod cross slope, it is 0.04%, that is given the question. Yes, that is all gutters is uniform cross section with 0.04 cross slope. So road, it is 0.04. So it is gutter cross slope is also 0.04, but we have to uncheck this depressed gutter. And the other information is inlet location. So for our first inlet, its location is on grade, so we will select on grade. So for the on grade, further we have to select the bypass target. Bypass target is 1 to 2 because it is given. I will show you. Bypass target is 1 to 2 and longitudinal slope 0.01 and manning 0.013. Okay, longitudinal slope 0.01 and manning's value is, here you can also select. So 0.013 is basically concrete gutter, asphalt pavement, smooth roughness value. So make sure that this depressed gutter option is unselected. Okay, so inlet information has been entered, so leave these information and uncheck design inlet opening. Now click OK. Main thing, desired sum depth. Desired sum depth is 20 centimeter. it is. It is, yes, the depth that 20 centimeters, it will be 0.2 meter. Okay, so now click OK. One main thing is that these are the design constraints, so we have to put it first of all. So here the cover, slope, maximum spread and sag, and its depth and minimum efficiency and grade. So for this purpose we will go to the analysis and check default design constraints. So here the minimum velocity is 0.525, so make minimum velocity equal to 0, and so here it is not given the velocity, so make it 0 to 5. Cover is given 0.5 to 5 meter, so make it 0.5, and the maximum 5 is good, and the minimum slope is 0.001, so it's not, make it 1. Okay, so for the gravity pipe, so these three default constraints value has been updated. So leave the node option and come to the inlet. For the inlet, the maximum spread in sag is provided is 2.5, so make is 2.5, and the maximum depth in sag, that is 0.15, so it is also 0.15, make it. And minimum efficiency on grade is 50%, so it is all by default is 50%, so close it. So this information has been updated. You can also verify it by going to the analysis, define. So as you notice that gravity pipe, so these are the default constraints, and for the inlet, so maximum spread has been updated, and all these values. Okay, previously we have added the information of the inlet 1, now we will update the information of inlet 2. So general name is I2, so this is the ground elevation, it is 42.75, and we will set its rim elevation equal to the ground elevation. Now come to the head loss. So head loss method is given as standard, so, and the head loss coefficient given is 0.5. Now moving to the catchment, concentration is 15 minute, and head catchment area 0.7, 0.6. 0.7 is catchment area, and inlet coefficient is 0.6. Okay, coming to the inlet information, so check the inlet grade D11A, and grade length is given 0.5, clogging factor is given 20%, as we previously entered in the case of inlet 1. The road close slope is given 0.04, and just uncheck the depressed gutter. Okay, so our second inlet I2 is in sag, so that's why I have by default we will check in inside. Okay, now moving to the flow, just leave it. The design, just uncheck inlet and decide some depth that is given, that is 0.2 meter, basically it was given 20 centimeter, so make it okay. So coming to the I3, its ground elevation is 42.86, and set the rim elevation equal to the ground. Okay, head loss method, it is standard, and head loss coefficient as we entered previously is 0.5. Leave the diversion tab, come to the catchment, concentration 15 minute, and catchment area 0.8, 0.9, that is 0.8, and that is 0.9. Okay, so coming to the inlet information, inlet type is given, so that is grade D1 Okay, grid length is 0.5 as and the logging factor is 20%. Okay, and the road cross slope is 0.4 and cross slope will be equal to that of the gutter cross slope, but it will not be depressed gutter. Okay, and the third one is also in sag location, so we will make in sag flow, just leave it, come to the design elevation is 0.2 meter. Okay, design inlet opening, just leave it. So all this information have been added. Okay, here you can see that. So here all the information of the inlet, okay, have been added. Just one thing I want to explain, so that maximum spreading sag depth grade efficiency that we added in the by default, so these have been updated here. Okay, so now we will update the information of the pipelines. So click here on the pipes. So in the statement it is given that all pipes are concrete circular one and their length is 40 meter. Okay, so we will make it P1 circular and check is concrete manning toughness. Okay, and this section by default 300 millimeters, so leave it 300 millimeter by default. Okay, and here we will set its length of 40 meter and inward elevation, and this elevation will be calculated when we design it. Okay, so here section shape circular, material concrete, roughness 300 and length. Okay, on the profile, on the design, so this will be design, just click OK. Now coming to the P2 circular concrete and average its length of 40 meter. These information are given here. Okay, and just click OK. And this is the third pipe, P3 circular concrete, and this length is 40. Okay, click here. Okay, so inlet information, pipe information have been added. Now outlet information is remaining. So for the outlet, okay, what we will it is given that the ground elevation of the outlet is given, that is 42.71 and it's a free water. Okay, 42.71. Ground elevation is 42.71 and it is the free outfall, so by default it is selected, so we will just update the ground elevation of the outlet. Okay, so we will remain it as so. Okay, just click on here. So all the information related to the inlet, pipes and outlet have been added. Now we will add the rainfall data. So the return period is 10 year and the time of concentration 15 minutes and the intensity is 50 millimeter per hour. Okay, so now we will go to the go option. Here you notice that there is a scenario based rainfall event. So for the rainfall event we will click on the three dots. Okay, by default there are three return period, 2 year, 5 and 10 year, but we have been given the rainfall intensity against that 10 year, so it is 50 millimeter. Here you can notice that it's by default unit is millimeter per hour. Okay, and our time of concentration, basically time of concentration is 15 minutes. So we have wrote down our intensity value against 15 minute time of concentration. Okay, so now we'll click OK. So here it is saying that the empty columns and rows will be deleted, okay, because they have no data. Okay, so here you can, when you click, you notice that only the 10-year return period rainfall against the 15 minutes rainfall have the intensity of 50 millimeter per hour. Okay, now click here. So we have added the rainfall data as well. Now we will click on the design, because we have to design the pipe size and their elevation and some elevation as well. So we will click here on the design and go option. Okay, so here it is saying that the design calculation may modify the physical property alternative. Would you like to create a new alternative to capture this modification? Yes. So here we will write the name of 10 here, 10-year design, because 10-year rainfall data is given. Okay, here you notice that there is problem is coming. Input data includes rational loading, but no rainfall data is active. So what is the problem? We will go to the okay. 10-year return period. Okay, click here. We have to select the 10-year, then we'll click on the design. No, now it has been, because previously we haven't selected the rainfall data. So these are the results. So only one warning is showing, that is inlet 3 fails maximum gutter spread constraints. Okay, I will maximize it. So these are the results, and these are the inlet. So here you notice that our one constraint was the maximum gutter spread should be 2.5, but it has increased 2.68. We have to minimize it. Okay, these are the capture efficiency. Okay, minimum capture efficiency is 50%. All these are above, so it is good one. So at the inlet, so we have get the bypassed flow and intercepted flow. Okay, so this is one warning, we have to remove it. Coming to the below, these are the design information of the pipes. Here the other thing, that is gutter depth. Okay, the gutter depth here against the gutter depth was minimum of 0.5. So these all are in the range. So for the pipe networks, so this is the size calculated. By default the size was 300, but here the minimum size against the P1 is 375 millimeter, and the other are 450 and 450. And circular shape, length, total flow in the pipe, average velocity, hydraulic grade, upstream, downstream. Okay, these are the total flow, ground elevation, hydraulic. Okay, now I will close it. Now go to the profile. Okay, so starting from the inlet 1 and stop with the outlet 1, finish. So here you notice that this is the profile. You can also adjust it according to your. Okay, so what it is showing, here you click here. Okay, now it is visible. So this is inlet 1. So here the sump elevation is 41.72 and ram elevation, that is equal to the ground elevation. So this is the pipe 1, this is pipe 2. The blue line shows the water surface elevation. As you notice that the blue line it means the water is under the gravity, but close to the inlet 2 the flow is pressurized one, and in the pipe 2 the pipe is flowing partially full, so it is gravity flow. Okay, So you notice that the pipe sizes, the inward elevation, slope, all this information has been added. Close it. In the same way, you can see the profile of from the I3 to 1. Just click here, and so these two black lines show the diameter of the pipe. Okay, so it means that the pipe, our design is good one, water is not overtopping, and the flow is so other thing, we can also click here and outlet and go to the design. Here you can see the maximum spread that is given. Come to the inlet. Okay, yeah, the inlet one. Okay, so this is the intercepted flow, bypass flow, gutter, spread width, gutter depth. So these informations are given. Okay, so coming to our first question. So our first question was by creating the model. So let us know what are the reported design warnings. So as I told, go to the table and results. Our first warning is inlet 3 fails maximum gutter spread constraints because maximum is 2.5 and it has raised to the 2.68. So we have to minimize it. Okay. The second one, what is showing, modify the storm saver system to overcome the warning in part A and fill out the following tables. Okay, so what we will do, we will, for the I2, there is the I2, yes, warning in the I2, inlet 2, sorry, inlet 3. So for the inlet 3, we will go to the inlet and change its type. We will go from D1A to combination. So I will show you the picture of the inlets. So this is the inlet D1, grade D1. Okay, so when it is the combination one, so combination means there's the opening in the curb as well. Okay, so we have now selected the combination D1 because we have to reduce that gutter spread. Okay, that is maximum 2.5, but it is increased. So let's see, they make other information by default and check it what happened. Okay, click yes, go to the go command. Now we have only make analysis. Okay, so I hope that warning has been adjusted, so we don't find the warning. That's good one. Increase the size, and I3, the maximum gutter spread is 1.5. Okay, so it has been reduced. So our first warning has been that warning has been rectified. Now it is saying that we have to fill out this from sump elevation, inlet depth, gutter spread. So as I show that, for that information, just click on the go, and this the result come down. So these are the information, these are the results of the just like the sump elevation, inlet depth, gutter inlet depth, and the gutter spread width and gutter depth is given. Gutter spread and inlet depth, that these two values will be taken from the results. Okay, total intercepted and bypassed and capture efficiency, that is the capture efficiency, and this is total intercepted flow, that is total bypass flow. I think sump elevation is not given, so for the sump elevation, just click on in the inlet and go to the design, and this is the desired sump, no, sump elevation. Yes, the sump elevation is 0.2 sump elevation, because yes, it is 20 centimeter. Okay, inlet depth. So here that is the inlet, so gutter depth that is equal to the inlet depth. So in this way this table will be updated, and this is the table for the pipeline. So we have to enter the pipe diameter, profile type. Okay, now go to the go option, result, come down. Okay, so come down, this is P1. Okay, so this is the pipe section. So all the pipes, you know, P1 is 375 millimeter and the other two are 450. Circular, upstream crown elevation, downstream crown elevation. Hydraulic, okay, hydraulic grade downstream, hydraulic grade upstream. So this is the hydraulic grade upstream, hydraulic grade downstream. For the upstream crown elevation, downstream crown elevation, the profile type, we will go to the, for example, just click on the pipe, and here go to the profile. Here you notice that the profile type is M1, composite pressure M1 profile. Okay, this information will be taken from this one. For the crown elevation, here is information 42.3, and for the invert that is 41.92. So this information will be taken back in, same like in pipe 3. Go to the profile. Here the profile is M1 profile, and these are the ground elevation, ground cover, all these information are given. So invert elevation, depth, hydraulic grade line, crown. So these have been updated in this way. Okay, our second, our C point is the sag. Basically here the 50 years return period, rainfall intensity has been given. So we have been asked to design it. So whether it will be good, our the design against the 10 return period is compensating this flow or not. If it is not, then we will redesign it. Okay, for the storm saver condition. So just save this model. Okay, so now what we have to do, we have to select on the row, and there we have to add the other return period data, that is against the 50. Okay, against the 50 the rainfall intensity is 90 millimeter per hour. 90 millimeter per hour. Okay, now we have selected it. Okay, just I want to say that if I select 50 air rainfall data, but I will use the same invert elevation and the pipe size that was against the 10 return period, then I will check what it happened. Okay, so here notice that warning has been added. So inlet 2 fails maximum cutter spread, and inlet 1 that is flooding occurring, inlet 3 that is flooding occurring, pipe 2 and pipe 3 are not pipe discharge capacity is above full flow capacity. So how? I will show you. You go to the profiles. Here you clearly see the water is above the inlets. It means that there is a flooding condition. Okay, the flooding condition, it means that our requisite pipes capacity is not sufficient. We have to redesign it. Okay, same like I3 to O1, finish it, and here you can also see that. So our I3 water is on the top of the ground, so it means that there is the flooding condition. So hydraulic grate line is above the pipe cover, so this is the condition, we have to redesign it. Same like here, so if this is the condition, we have to redesign the storm side. So how we will do it? Just click on the go, okay, select 50 and click on the design and press OK button. Yes, so here we will name the 50 year design. Okay, so now when we click on the, so here only there is one warning, that is inlet 2 phase maximum gutter spread constraint, but there is no flooding condition, so that is very good one. Only I2 gutter spread is 3.39, but there is no flooding condition. So that is very helpful. What we will do, we will change the inlet shape I2. Okay, I2, click here, inlet characteristic is, now we will use the combination one just as previously, just other information same, click OK. Yes, and now see what happened. Analysis, just yes, 50 years. Now make the analysis. Now no any warning related to the gutter spread and the flooding condition, so all these things are under the control, and new section size has been calculated. So the minimum pipe, that is P1 is for 50 millimeter and P2 and P3 are of 525 millimeter. Okay, so we will also check this profile I1 to O1, so you can see that, but there is no flooding condition. Okay, there is no flooding condition. Here in the pipe 2, the water is under the gravity and is partially flowing, but in the pipe 1, so that is at the start it's pressurized flow. Here water grade is little bit higher. Okay, so section C has been calculated. Now coming to the D option, if the storm sewer system drained into the sea, okay, we will say it was a free flow condition. So analyze the system for different tailwater elevation and examine the pipe profile for each case. Now we will change the outlet tailwater. Okay, here we will select user specified. So now as we notice that our sump elevation is on the 41.3. For example, we will say that our sea level is below that sump elevation in 41. Okay, yes, go to the option, click 50 air, now click on here. Okay, there is no any harm. We will also go. Okay, so under the control, same condition, but if we increase the tailwater elevation, for example, if we make equal to sump elevation 41.3, so now check here, so what happened. Okay, so there is no any warning. Now we will increase our tailwater elevation to equal to the rim elevation. So for hydraulic grade line, no, rim elevation, that is 42.71. Okay, so now check what happened. Okay, click go. So here you notice that warning is coming. I2 flooding is occurring. Calculation continues with hydraulic grade reset. Okay. So as you notice that when the water level of the sea comes on to the ground level, so there is the flooding condition. Okay. So these are the effects when the tailwater changes. So we have examined the different tailwater conditions. So I will make it to the free fall, okay, as original. So analysis, so it has been successfully loaded. So this is all from my side. So here in this tutorial we have plotted and we have made the network of the storm sewer in the StormCAD software, and we have calculated the inlet information like some elevation and the inlet depth, gutter spread, or gutter depth, capture efficiency, total intercepted flows, and the pipe. So I have calculated the pipe diameter, profiles, upstream and downstream hydraulic grade elevation, and their hydraulic grade line. And we have also know how to draw the water profiles. Hope this tutorial will help you. Thank you.